Today's presentation is climate change dangerous? We're going to explore many facets of climate change and look at the big picture instead of just little snippets that you hear in the news. You're going to see a lot of things today that you've never seen before. Earth's climate pulse. This is the main thing we're going to be talking about today. Here's the proof of global warming in a nutshell. Starting in 1860, you can see how the underwear got smaller and smaller right up to 2006. Perfect proof of global warming. But in all reality, global warming is real. There's no doubt about it. Climate change is real. There's no doubt about it. And natural cycles are real, and global cooling is real. And we're going to look at all of this. Well, the eastern two-thirds of the nation and up here in Maine, past couple of years, we said, and what did winters look like before global warming? First, we'll look at the great temperature pause. And everyone's heard about the polar vortex the past couple winters. 2013 through 2015, for instance, 2014 was the fourth coldest winter in the eastern United States. 2015, coldest winter since the 1940s in portions of eastern Canada and Greenland. 2013 and 2015, the Antarctic had record high ice extent at the end of their summer. So what is happening? Because at the same time, we have warmth on the west coast of the United States. So what's happening here? First of all, I mentioned the great temperature pause. And here's the big pause. We're looking at an 18-year period from 1996 up until present. You can see the temperatures pretty much up and down through the 18-year period. The blue line through the center of it is kind of the average. So you can see the temperature hasn't really risen in 18 years. It's just up and down, up and down, up and down. This is called the great temperature pause. But we don't see any global warming here. So there's a red flag. Why the pause in warming for the past 18 years? That's quite a question. We need to look at natural cycles. And that's what we're going to do. This graphic goes back 500,000 years. What we're looking at is 5 very specific cycles in the past 500,000 years. The red line is temperature. This is derived from the Antarctic ice cores, very old ice. The blue line is carbon dioxide. So what we're looking at, we go back 450,000 years, and we see it warmed up, very warm interstadial global warming. Then as the temperatures fall off over the next few thousand years, we go into about a 50,000-year period of the Glacial Period. In the Glacial Period, you have ice year-round all the way down to Cape Cod, Massachusetts. Central New England have ice a mile thick year-round. These cycles come about every 116,000 years. Now let's specifically look at the one 338,000 years ago. The red line is temperature, deep in a glacial period. Then over the course of only about 5,000 to 6,000 years, look at the red line go up. Tremendous warming, just a short period of time. The blue line is carbon dioxide. You can see that going up, but it follows the temperature. The temperature goes up first, followed by carbon dioxide. Carbon dioxide is just a byproduct of global warming. Once the temperature hits the peak, the carbon dioxide is still coming up. Carbon dioxide doesn't peak until about 2, 3, 4, maybe as much as 7,000 years after the temperature peak. So if carbon dioxide is because of global warming, why is it coming up after the temperatures? Instead, everyone has it backwards. It's the temperature, not everyone has it backwards, but people that regard our global warming as man-induced or human-induced have it backwards, because it's the temperature that goes up first, carbon dioxide goes up second. And as you notice, as we come off a very warm period, temperature starts to fall like a rock. But there's carbon dioxide still up very high. If carbon dioxide causes global warming, temperatures could not have gone down, but they did. Instead, if we followed the carbon dioxide rule that everyone's talking about on human-induced global warming, we would have had runaway global warming way back 338,000 years ago. But that didn't happen, did it? Instead, we have cycles. So we have cycles every 116,000 years. We get over to the present time. 15,000 years ago, we were in the middle of a 40,000-year glacial period. Then over the course of only about 5,000 years, temperatures warmed up dramatically and peaked 7,000 years ago was our temperature peak. At that point, we'll go back one slide here. At that point, 7,000 years ago, we had 50% less ice in the Arctic than we do today. 50% less ice. And then the blue line is the carbon dioxide, which is today, about 7,000 years later. Now we're peaking on the carbon dioxide, just like we did way back on some of the other cycles. So we're supposed to have warm temperatures today and high carbon dioxide, just a perfectly natural cycle. Again, looking at the cycle, this is back 11,000 years ago in the Ice Age. Here's 7,000 years ago. I spoke about that. That was our warmest period where we peaked. Our temperature peaked 7,000 years ago. 50% less ice in the Arctic. Then we see cycles that come like clockwork. We cool down, warm up. That's 4,500 years ago. Cool down, warm up, cool down, warm up. Here's today. We're in a warm up again. Perfectly natural. But look at the yellow line. Each one of the warm ups are getting colder and colder. That's because we're 7,000 years off of the peak of the 116,000-year cycle. So everyone's talking about global warming. Wow, we're going to kill the planet. No, we're actually cooling down, even though we're in a small global warming cycle, a natural one. Taking a closer look at what's happening today, this graphic goes from today back to 800 AD. This is temperatures. What we see is 5 global warming cycles. This is back 8 to 900 AD. We see 2 temperature spikes right here. Every global warming cycle has at least 2 temperature spikes. When the temperature spikes, it also levels off, pauses for about 10 to 15 years. This is called a pause. So we see 2 spikes and 2 pauses in that global warming cycle. In this global warming cycle, these global warming cycles come about every 230 years. And then in this cycle, this is in the 1300s. In the 1500s, 2 very nice spikes and temperature pauses. Back in the 1700s, and here's today. There's the 10-year temperature spike and pause in the 1930s. And our temperature spike and pause now that is now ending. Those are perfectly natural signatures of the global warming cycles. And as we look at this cycle, it's perfectly normal as compared to all the other ones. Now we even bring it in a little bit closer. This is a 30-year period, 1880 on the left to present day today. What we saw was it was relatively even temperatures from 1880 to about 1930. But 1930, a great warm-up, but the temperature paused. Temperature paused for about 10 years. Remember, it talked about every global warming cycle has 2 warm-ups, 2 pauses. That's warm-up and pause number 1. Then we cool down for about 50 years, and that's our current one. The past 18 years, warm up and a pause. This is a perfectly natural global warming cycle. Now we're going to take a look at the Earth's climate pulse and the possible cause for global warming and global cooling. First, we're going to look at the Milankovitch cycles. These are proven scientific cycles. The Earth revolves around the sun. Every 120,000 years, the Earth comes in closest point to the sun. Then it goes out beyond the sun. When it comes in the closest, it's global warming. When it swings out away from the sun, less solar radiation, glacial periods for about 40,000 years. So here we were about 7,000 years ago. Now we're 7,000 years off of a peak. We're actually heading towards a glacial period. But don't worry, it's quite a ways away. We're talking 20,000 years or so. But we're coming off the warm peak. This is a proven scientifically. Now, another look at the Milankovitch cycles, we're going to look at what we call the lunar solar precession, kind of a subcycle. What we're looking at is the interaction between the moon, Earth, and sun. If it wasn't for the gravitational tug and pull of the moon and the sun, the Earth would just spin out of control. We have to have the gravitational cycles of these two bodies. The greatest gravitational tug or pull by the moon is within plus or minus 28 degrees of the equator on Earth. However, in the oceans, the greatest influence is in the high latitudes, like up around here in Maine, where we have very high tides. What we're going to do, we're going to look very closely at 9-year cycles, 2-year cycles, and 230-year cycles of the very strong gravitational cycles. Well, we showed that the Earth has an elliptical path around the sun. Well, the moon also has an elliptical path around the moon, around the Earth, just same way. So there are very strong cycles where the moon comes in close to the Earth, and when it's also in alignment with the sun, we have a double gravitational pull. When this happens, we can have gravitational pull 47% above normal, above a normal lunar cycle. That's a huge amount, 47%. You can imagine what happens, or you can't imagine really, but we'll touch upon it just a little bit. What we have is the full moon on one side of the Earth, new moon on the left side of the Earth. The very strong gravitational cycles I'm talking about take 9 years to go from high in the sky in the northern hemisphere, down to the southern hemisphere, and up to the northern hemisphere. That's a 9-year cycle. Full moon's doing the same thing on its cycle. That's like taking a wrench on a pipe and just wrenching the pipe. Great forces on the Earth, on the inner core of the Earth, which is liquid iron, hot iron. The inner core of the Earth can bulge by 1.4 kilometers during strong gravitational cycles. That's a huge amount, 1.4 kilometers. And the oceans have a bulge in it. So this is great stresses on the Earth and also the atmosphere and oceans. And this is what an actual cycle looks like. This is high in the sky in the northern hemisphere. This is the very strong 47% above normal gravitational pull on the Earth. And then it takes 9 years. It'll go down to the southern hemisphere. Then the moon comes up. But it takes 9 years for the full moon to get back high in the sky in the northern hemisphere, 9-year cycle. It takes another 9 years for it to go down the southern hemisphere, back to the northern hemisphere. That's a 9-year cycle. But you also see that the right-hand cycle and left-hand cycle, it's higher in the sky. That's an 18-year cycle. So we're looking at all kinds of cycles here. Here's an actual plot of the 9-year cycle. The very strong gravitational cycle of the moon and sun, high in the sky in the northern hemisphere in 1990. Then it takes it 9 years, goes southern hemisphere, back up to the northern hemisphere. 9 years, that's in the year 2000. And then it took about 8 years, a little over 8 years, for 2008. We're going to look, see what happened on these cycles. Well, first of all, here's the United States temperatures from 1880 all the way up until present. You can see little blips in the temperatures. Those blips all happen about 9 to 10 years. 9-year cycles of the gravitational cycle. You think that's by chance? Not really. It's showing the influence of the lunar cycles on the Earth. Now what we want to get into is the Arctic and the Antarctic. This is where global warming begins and global cooling begins. What we're going to look at first is the warm conveyor belt of the warm ocean waters in the North Atlantic and South Atlantic. Now, you thought I was going to talk about the Arctic. Here we are talking about the oceans in the South Atlantic. Bear with me, and we'll show you what's going on. It's a conveyor belt. The warm water comes off of Africa, right up along, swings just southern tip of Florida, up the east coast of the United States as the Gulf Stream. Then it heads across the Atlantic, back to Africa. But just before it gets to the eastern Atlantic, there's a little split. Here's England. It comes up towards England. That keeps Western Europe warm. Up to the north, you can see it's kind of cooling down, but we want to look at this portion up to the north. What happens up in that area during the 9-year cycles? Because remember, as we talked about the moon, where it's doing a great wrenching on the Earth, it's also causing bulges in the Earth's in the oceans of the Earth. And the bulges will go up and down with the gravitational cycles, acting like a plunger. And what we're going to do is talk about a plunging effect of the ocean. This graphic, I'll give you some bearings here. This is the North Atlantic Ocean, called the Ural Straits. This is Northern Europe, Russia, Alaska, Canada, and Greenland. In the middle is the Arctic Ocean. And Arctic Ocean is all water and ice. There's no land in the Arctic. So what we want to do is see what happens in the Arctic. Well, in 1990, a very warm surge of water went up in the Arctic, plunged up into the Arctic. It takes it 13 years to circumvent the Arctic as it mixes with colder water and finally fades out. 13 years. What that did was it started the great meltdown of the Arctic in the 1990s. Got to remember, this is all ice. Ice in the Arctic melts from the bottom up, not from the top down. 9 years later, 1999, a very warm surge of water came up into the Arctic, again, taking 13 years to circle. Then in 2008, another warm surge, but not quite as warm. Now let's look at these a little bit more in depth. Talked about 3 warm water surges. First one in 1990. This is where it occurred on the gravitational cycle. The strong gravitational cycle caused a plunging effect and the pulse of the warm water into the Arctic. 1999 occurred on the exact same spot of the gravitational cycle. And this was a very warm pulse of water, very warm. Then in 2008, look at that, occurred on the very same spot of the cycle. The cycles on the left and right were not quite as warm as the one in the middle. That's a signature of the global warming cycles, like in 1930, where it got very warm for 10 years. All the twin temperature peaks we see in global warming cycles. Again, pulse comes up, takes 13 years to circumvent the Arctic. Now let's see what happened to the ice when the warm pulse came up. As we indicated, first warm pulse came up 1990. The black lines show how much ice is in the Arctic. The upper portion means a lot of ice. Down below means there's less ice right in there. We're back in 1979 right here. 1990, the warm pulse came up in, and the ice started to melt in the Arctic. And everyone around 1996 said, wow, look at the ice go in the Arctic. Then it started to recover. 1999, that very warm pulse of water came into the Arctic, and look at the meltdown, the loss of ice in the Arctic, where they said in 2007 and 8, the record lowest ice in the Arctic. However, there was less back 5,000 years ago. Then it started to recover, and the third pulse came in 2008, but not as warm, but it did cause some more meltdown. But now what we're seeing is that water's cooled down, and we're starting to see a dramatic increase in the ice in the Arctic. We're out of the 3 warm pulses. The next pulse up in the Arctic will be a lot cooler, and it'll cause probably no melting at all. This is the high Arctic temperatures. The green line is the normal temperatures in the Arctic for the full year, the normal temperatures. This period is May through August, which is the summer in the Arctic. The red line is the temperatures in the high Arctic. If you noticed, and this is for the period 2013 and 2014, the 2 Arctic summers. If you notice from May all the way through August to September, the temperatures ran below normal for a 2-year period in the Arctic. They had 115 consecutive days of below normal temperatures in the Arctic. 115 consecutive days. The last time there were at least 65 consecutive days was way back in 1979, a long time ago. This shows the Arctic is cooling rapidly now, rapidly. So the old saying, did the coal miner's canary just flutter? Did global cooling just begin? Well, we noticed the ice recovery happening in the Arctic. Let's look what's happening down in the Antarctic. Is it happening down there also? Well, here's the ice around the Antarctic. In 2015 was the second time in the past 3 years that the Antarctic had the greatest ice extent on record. 2 out of the last 3 years, greatest ice extent on record in the Antarctic. And the third year, but didn't have it, was it had the 7th greatest on record. The Arctic is cooling off rapidly, just like the Antarctic. Both of them cooling down rapidly. Taking a look at the ice in the Antarctic, going back to 1980, this is pretty much from satellite data, and it showed in 2006 and 2010 had great ice loss in the Antarctic, a lot of ice loss. And everyone is worried, oh, the Antarctic, we're going to lose the Antarctic ice. Look what has happened since. The past 3 years, really recovered. Here's the past 2 years up here. Right now, during the past 2 years, it's the most ice in the Arctic, extent-wise, since the 1970s. We're restoring ice rapidly in the Antarctic. More ice means more cold air available. It's like an ice box. So the great temperature pause and polar vortex we've been talking about temperature pause. We're going to get into the polar vortex now. And what the polar vortex did in the Arctic, 2013, the Arctic had the shortest summer, or it had the summer about 125 consecutive days below normal, as I indicated, and the most since 1976. And in 2013, the Arctic had the shortest summer since 1976. Sure doesn't sound like global warming. In 2013, Arctic had a 26% increase in Arctic ice. Doesn't sound like global warming. Antarctic in 2014 had the most ice since 1979. That doesn't sound like global warming. United States in 2014 in the upper Midwest, coldest since 1979. United States 2014, fifth coldest in most of the United States, the eastern two-thirds. Lake Superior in 2014, they didn't have ice out completely until May 27th, latest in 40 years. So what's going on with our weather pattern here in the past 2-3 years? Everyone's even talking about it's warm on the West Coast, it has to be global warming. Drought in California must be global warming. Well, here's the weather pattern during the past 3 years. This is Alaska, Canada, here's Maine over here, and Greenland. The weather pattern, the blue line, signifies the jet stream. This is what the storms move along the jet stream. Warm air has been, for the past couple of years, pulled up into the Alaska area that has kept the West Coast warm and dry, very drought. This is a 26-year cycle for the West Coast. Every 26 years they come into an extended drought. To have an extended drought, you have to have a weather pattern like this. So this weather pattern set up in association with the cyclical 26-year drought. Meanwhile, the Arctic was cooling down drastically. More ice in the Arctic. This made more cold air available. So this pattern of flow, as it came up around Alaska and then down into the midsection of the United States, the cooling down of the Arctic enhanced everything. So between the two, we had a drastic drought on the West Coast and very cold weather in the East. These are all cyclical, and this cooling down, this also happened back in the 1990s, but we didn't get that cold. So this is signifying the beginning of global cooling. And this is what happened in 2012 through 2014. In August of 2012, that's the end of the Arctic summer, you can see it was pretty ice-free in the western half of the Arctic. 2013, 2014, very cold in the Arctic. Into the summer, look at how much more ice there was in the Arctic. A lot more ice. That means you have more cold air available as a high-pressure system sits on top of it. Then what happened was our polar vortexes formed and came down, one after another, the past couple years. That's global cooling, not global warming. Again, we talked about the wrenching of the Earth, the oceans, the atmosphere. But what happens when on a long-term pattern, the full moon and new moon cycles get pretty much on the same plane? Does it enhance our gravitational cycle and even cause a bigger problem? Let's take a look. We're going back, the red line is temperatures, we're going back from present all the way back to 949 AD. That's our global warming cycles in here, mixed in here. This is the 1500s, 1800s, and now. Now what we put in here in the yellow line is the long-term average of a very strong full moon cycle. And you can see over time it goes up higher in the sky, then down, up, down, down. You can see cycles in here. Well, over a long-term period, when the full moon reaches the bottom point of a cycle, this is in 1275 AD, you have a global warming, beginning of global warming. There's your two twin global warmings. Every cycle, remember, has two peaks of global warmings lasting about 10 to 15 years. Then when it comes off the right-hand side of a cycle right here, you come off global warming and rapid global cooling for the next 30, 50 years. This happened again, 1530, 1575, then you come off the cycle, rapid global cooling. Then you come down in the cycle, there's global warming, come off the cycle, rapid global cooling. And here we are getting to present, 1930, right on schedule, the 10-year warm period. And wow, where are we here? We're on the right-hand side coming off the cycle. This is just about 2019, which is almost present day. And we're going to come off that cycle, and yeah, you betcha, we're going to have rapid global cooling. Now what we're going to do is, you can't see this one very well, but we have, that's the temperatures again. This is the full moon, and I put in the new moon in red. What I wanted to show is where they intersect. There's the red coming down, and that one coming up, where they intersect. I'll put them all in here. So where they intersect is where you have a global warming. They intersect the 10-year global warming cycle. Same thing here. There's your two twin peaks. They intersect your two twin peaks, and here's our twin peaks now. So by using those, we can tell when we're coming onto global warming and coming off of global warming. Now, what we want to look at is a lot of snippets we've seen in the news releases by government agencies that are not really, they're more political than anything. Temperature fiddling, number one, eliminating the warm period in the 1930s. Remember, I showed it very warm during the 1930s for 10 years. This could end up being the biggest science scandal ever. Fiddling with temperature data. But temperature data is collected in remote, sparse areas such as the Arctic, Antarctic, oceans, and even in western and northern Maine where it's very sparse data. So what they have to do is they take the closest reporting stations they can, they may be 100 miles apart even, and average them together. Are you getting the true temperature? No. Those are apart from each other by quite a ways. And also using some satellite data to estimate the temperature. So these are estimated temperatures. Well, these estimated temperatures are used by the United Nations Intergovernmental Panel on Climate Change for scientists and politicians for the use of climate change studies. But this is estimated data. The data is collected by the Global Historical Climate Network, analyzed and changed by Goddard Institute of Space Studies and the National Data Climate Center of the federal government. Now, what they want to show is, remember I showed a very nice warm 1930s. This is what they want to show us, 1910 up until present. They want to show a nice even curve of a steady increase in temperature. This is what they want to show, because they want to say, well, global warming is continuing. Global warming is continuing. But that's not what's happening. That's not what's happening, because this is the graphic that I showed you where here's the temperatures in 1930s and now, where we have that warm period in the 1930s, then cool down to 50 years and another warm period. This is what actually happens. But you can't draw a nice straight up line showing global warming. Doesn't look very good. It really interferes with everything. So, what are they going to do to get this? Nice straight curve. Well, it so happens, there's a gentleman just a short time ago, a few months ago, he looked into the old temperature data in Greenland, at a spot in Greenland, and one in Siberia. And what he saw was, okay, in the old data, there's our warm period in the 1930s, and also now. So that's what we're used to, the warm period, cool and warm, our global warming cycle. Well, the new plot, new data up there, now looks like this. I have a red reference line here across to show the peak right here. There's the red reference line. From year 2000 backwards, they dropped all the temperatures, lowered the temperatures. Now, you don't have this warm period. Instead, you're seeing more of an upward trend of temperature. Siberia, that was the data that everyone had been looking at. This is what it looks like now, after they fiddled with the temperatures. Lowered all the temperatures to show a steady increase of temperatures. This is temperature fiddling. Now they have the graphic the way they want it. But is it the truth? No, it isn't. Temperature fiddling number 2, politically driven press releases. And they are worded politically if you read them. We all saw this in headlines back in January. 2014, the hottest year on record globally. That's based on a 100-year average. This was put out by NOAA and NASA. They said that last year, 2014, surpassed the all-time hot years of 2005 and 2010. Surpassed them globally. And that the globe is likely warmer than it was in at least 5,000 years. Well, I've already showed you it was warmer 1,000 years ago, warmer about 2,500 years ago, 4,000 years ago, 6,000 years ago. Well, in reality, Great Britain's Meteorological Office called out NOAA and NASA on this and said, this isn't true. So NOAA had to recant their press release. And they came out and said, well, it's really a 38% chance that last year was warmer than 2010 and 2005. And it was a 62% chance that last year was actually colder. But this really didn't make it into the news. But that's the truth. It was not that warm, as warm. Now, how did they come up with their figures? Big red flags here. And this is pretty important on how they came up with their figures. Because this is what they said, last year was the warmest on record, but it was actually probably cooler than those 2 years, and no one even mentioned 1998. This is how they did it. This is last year, 2014, the land areas. The blue shows below normal temperatures, the red above normal temperatures, the gray is normal temperatures. And the black line is within plus or minus about 30 degrees of the Arctic and Antarctic. They did not use any temperatures plus or minus 30 degrees of the Antarctic and Arctic where it was running cold, colder than normal. They used the land temperatures in this graphic, but the problem is the land temperatures showed it only about average, maybe a little above average. So what they did was they added in the ocean temperatures. And the ocean temperatures at the end of the global warming cycle, which we're in now, it's like when you put a pot of water on the stove and heat it up. Then you turn it off. Well, the air around it may be starting to cool down. If it's nighttime, it's cooling down, the air around it. But the pot doesn't cool down that fast. And that's what it is on the oceans. It's not, hasn't cooled down yet at the end of the cycle, so the oceans are very warm. So they're putting the oceans in there. Temperature fiddling number 3, incorrect stories by the media. We all heard in the headlines back in March, record heat in Antarctica, continental. Well, when we think of the Arctic, we think of the Arctic Circle. When we think of the Antarctic, we think of the Antarctic Circle. The record heat was outside of the Antarctic Circle on the very southern peninsula. So this was a blown out of proportion story. Climate change consensus number 4, the last one on it. We have all heard 97% consensus. All scientists say that it is human-induced global warming. Well, Dr. Rich Toll, he's one of the lead authors for the Intergovernmental Panel on Climate Change, the IPCC, says that figure is bogus. Even he says it. Well, in reality, John Cook, who brought up the figures, University of Queensland in Australia, he looked at 12,000 abstracts from research papers that mentioned climate change. 12,000 papers. About 4,000 of them, which is 33%, did say that human activity is the primary cause. 33%. However, 8,000 of the papers, which is 67% of the papers, had no opinion. So 67% no opinion, but yet he's saying 97%. But 97% came from 97% of the 33% said it was the primary cause. He really finagled figures. Now, about the same time, a poll taken by Dr. John Coleman, founder of the Weather Channel, he asked meteorologists, is climate change mostly human-induced? Only 15% of them said yes. Only 15%. 85% said climate change is mostly natural. So this is a bogus consensus report, 97%. Again, in closing, I want to talk about, remember the 116,000-year cycles for temperature and carbon dioxide. We're supposed to be warm, and we're supposed to have high carbon dioxide today. We're right where we're supposed to be. The cycles, we had 50% less ice in the Arctic 5,000 to 6,000 years ago when it was much warmer than today, and the cycles are getting colder and colder. And on the last slide coming up, is climate change dangerous? Indeed, extremely dangerous. But it's not global warming that's dangerous. It's global cooling. Here's our 1, 2, 3, 4, 5, 6 global warming cycles the past 1,200 years. When we come off the global warming cycle, it cools dramatically during the initial 30 to 40 years. Normally, you have a very large historical volcano associated with this global cooling period at the same time. This is due to, as I've shown you, the global cooling and global warming cycles are caused by very strong gravitational cycles that cause stress on the inner and outer core of the Earth. That's why we also have volcanic activity during this period. For example, in 1816, and this occurred in quite a few of the other cycles, in 1816 we had the very large volcano Tambora in the southern hemisphere. 1815, year 1816, and this was about 10, 15 years into the global cooling cycle. 1816, the year of no summer, globally, because what happens is a very huge volcano spews up sulfur into the upper atmosphere. The sulfur is absorbed and mixes with the water vapor, which causes sulfur dioxide. Sulfur dioxide is very reflective, and it reflects the sun rays back into the outer atmosphere. So you have cooling of the atmosphere and the Earth for the next 1 to 2 years. So in 1815, volcano and global cooling. 1816, the year of no summer. Crop failure in Europe, parts of China. During the upcoming years right after that, 1/3 of Europe perished by famine, had crop failures, plague, because people died, and civil unrest. Lots of civil unrest because lack of food. And that was from 1816 up through a little bit after that. 1 billion people on Earth at that time. Right now we have 7 billion people on Earth. If we have crop failures, and it is likely coming, if we have crop failures, we're going to have huge civil unrest. There are 3 volcanic faults now being monitored around the world. Any one of the 3 can blow at any time. That's what they say. Any one of the 3 is as large or larger than Tambora in 1815. So it's not a question of will it occur during a global cooling cycle, but exactly when during a global cooling cycle. We're looking for the worst part of the global cooling cycle, the coldest part, to be right around, well, starting 2019, coldest part would be 2025 through about 2050. It's going to be extremely cold, but it's going to be periods where here in Maine, There'll be some years where you can walk across the ice in Casco Bay from Portland to Peaks Island. There'll probably be some periods where the mouth of the Chesapeake Bay will freeze over. There'll be many, many years where the Great Lakes will be completely ice-clogged. Won't be any shipping. The mid and upper Mississippi River also. This is going to have an interruption in our commerce and food supply. And this is coming. Thank you very much for inviting me, Debbie.
David, thank you so much. It sure sounds like it might be time to look for some property in Florida. I know I'm going to. Dave, let's go over your website again. It is globalweathercycles.com.
Correct.
And all of his email and contact information is there. You'll find out more there. You'll also be able to download the ebook Earth's Natural Climate Pulse, which has more information on it. He's a wealth of info, people. Thanks so much for listening, and stay tuned next week for more of Mind Your Own Business TV.